Okay, welcome back everybody. This is a quick lesson on Malus's Law. Hopefully everybody can hear me okay. To start out with, just a review from topic 5 and topic 6, we talked about electric fields and magnetic fields and how both of those fields had vector arrows when we worked on problems with them. And so because they had vector arrows, they also have vector components. And the basis behind Malus's Law states that if you have polarized light and you shine it onto another polarizer, there a component parallel to the polarizer will shine through, and that will determine the intensity of the light that goes through the second polarizer. Okay, so just to put it down here, you have an electromagnetic wave that passes through two polarizers. The intensity of the light can be controlled by the angle between those polarizers, or the angle between the electric field, the polarized light, and the second polarizer. Alright, and I'm going to skip this because we looked at it in class, and I'm going to look at this diagram here. This is, as you can see, you have unpolarized light here on the left, and the electric fields have many different orientations. And so that unpolarized light reaches the first polarizer, which is set up at an angle of 0, and therefore only allows vertically polarized light to go through it, which you can see right here. Okay. Then it comes to an analyzer, or a second polarizer, and that's this one here. And if I move the angle between the polarized light, which is this, and the polarizer itself, I can vary or control the intensity of the light that goes through. For example, if the polarizer and the polarized light have the exact same angle, this 0 and this is 0, the light that comes through is 0.5, and if I change it, okay, I can vary it accordingly as it goes. So 0.5 intensity here, 0.5 intensity here. This gives me a maximum transmission, 100% transmission. And then as I change that angle, okay, this component gets smaller and smaller, less and less intense, until I get to an extreme case of 90 degrees right here, and there the light is blocked. It's 0% transmission. Okay. Now, one thing that we did in class is we actually, you know what, I'm going to skip that too, and we're going to move ahead to the next part. So here's how this works. Electric fields, as we said, they're a vector. They have a component, they have a direction, they also have a magnitude. And as it turns out, the brightness of the light, or intensity, is proportional to the electric field squared. So if I'm considering our diagram here, here's my transmitted light, 0.5I, and then as I change it, you can see this component. Here, I'll do it this way. I'm going to reverse this like this, and put this at 90. Okay. Alright, so the vertical component of the polarized light is allowed to go through. There it is there. And the horizontal component of the polarized light is blocked. And so from this, by varying this angle, okay, or by default varying this angle, we can change the intensity of the light that comes through our polarizer. Alright? This is done by this relationship. Intensity of light is proportional to the electric field squared. And as we said before, if our polarizer is set up to be vertical, then the vertical component of the electric field, right here, the vertical component of it will pass through. Right? So the electric field that passes equals E, which is the hypotenuse, times cos theta. If I take this equation and square it, I get E squared of the light passes equals E squared times cos squared theta. And then, as we set up here, intensity is proportional to E squared, and so the intensity of light that passes is determined by the intensity of light before the polarizer, and the angle between them. That's known as Malus's Law. Okay, and Malus's Law has a number of applications, including stress analysis and LCDs and sugar concentrations, but it all works on the same concept. What you have is you have initially polarized light right here comes through, or you know what I can do in fact is I'll take this and I'll make this polarized, and then I take it with my polarized light at 100%. As I vary this angle, I vary the intensity of light that comes out. So I can have it at 0 like that, or I can have it at a maximum if I take this and pull it up like that. Okay? Again, that's the relationship. The angle between this polarizer and this polarized light determines the intensity that passes through. That's it in a nutshell. So take some time and try the IB questions and look over the textbook and let me know if I can help out in any way.